Okay, so there was kind of a surprise in the last example. Will there be a surprise in this one? We will find out. Okay, so we're going to find the solution. There's lots of ways you could start this problem. I think I'm going to multiply this bottom equation by -4. So then I can add the middle equation and the bottom equation. So the middle equation, I'm just going to copy that down. My goal here is to eliminate the x. And the bottom equation becomes, now remember you're distributing all the way across, so -4x plus 4y minus 4z equals 0. You might have noticed they all equal 0, which I don't know if that's necessarily an indication, but it does maybe look a little odd. Okay, the x's cancel out. Then we get 6y minus 10z equals 0. So the goal would be to try to find 2 more equations so we could eliminate x. So now, don't multiply by -4. Let's multiply by -2. Okay, so I'm going to copy the top equation, 2x plus y minus 3z equals 0. And then I'm going to distribute here again, but this time with a -2. Okay, when I add those together, the x's cancel out. That was supposed to happen. I should double check and make sure I wrote it right, but I think we're okay. Y and 2y make 3y, and -3z and -2z make -5z, equaling 0. Now, if I could just get that 6y and the 3y to cancel, so I'm going to multiply this one I just got by -2, and I'm going to write it underneath here. So I get -6y, I get positive 10z equals 0. So think about distributing. All right, great. Then those y's are going to cancel out. But look, the z's cancel out also. So we get 0 equals 0. That means it's a dependent solution. Because it's a dependent solution, they like share a line, and we are going to get our solution. There's like multiple solutions. We're going to get them in terms of one of the variables. And we're going to use x, but that's okay. You can take one of your equations then. So one that we've already done. I'm going to take the 3y minus 5z, and I'm going to say 3y minus 5z equals 0. I just used that one because the numbers are a little smaller than the 6y minus 10z. Okay, so what I want to do now is I want to solve for y. In terms of z, I said in terms of x, but we'll just see how this goes. All right, so we'll divide by 3. Sorry, I added the 5z over. I just did that without talking about it. Now I'm dividing by 3, so I get y equals 5/3 z. Okay, now I've got to plug that in somewhere to find x, right? Okay. So let's take this bottom equation. We have x minus, now what's y? 5/3 z plus z equaling 0. So I'm going to get x. I'm going to have to get common denominators here. So -5/3 z plus 3/3 z, because it was 1z, right? So a 1 is equal to 3/3. Okay. So I get x equals, not yet, x minus 2/3 z equals 0. So put the 2/3 z on the other side. X equals 2/3 z. Okay. So I said we were going to give them in terms of x, but we actually did it in terms of z. So that's a common way to do them. It's not the way the book did it, but I get, for x, I get 2/3 z. For y, I get 5/3 z. And then z is just z. That's an acceptable answer. A lot of times they do use z as the variable, but let's see what we could do if we wanted it to be in terms of x. Okay. Okay, if I wanted to get in terms of x, I gotta scroll up. It's not scrolling. Okay, sorry about that. I couldn't get my screen to scroll. Okay, so coming back to the equation, we're going to use the top equation and the bottom equation. So let me try to remember what those are. 2x plus 3y minus, was it 3y or y? It's not scrolling. It was y, minus 3z. Okay. Equals 0. That part's easy to remember. And let me get that out of there. It was plus the y, right? Okay, and then the bottom equation was, x minus y plus z. Okay, so x minus y plus z. Now this is a nice one to use because the y's are already going to cancel out. So we're just going to add them together, and we get 3x, the y's are canceling out, minus 2z equals 0. Now to solve for x, we would put the 2z on the other side, and you get x equals 2z over 3. Okay. Then what could we do? Well, that's the same answer we had, right? Oh, we didn't want to solve for x. We wanted to solve for z. Sorry about that. That's why it's all looking different. Still doing what we did, but we won't divide by 3. We will divide by 2. There. Now we get z. Z equals 3 over 2x. Now that's in terms of x. Z is in terms of x. Okay, and that's what we were going for. Now what was my y? My y was 5/3 z. But I just got an expression for z in terms of x, and I forgot what it was already. 2/3. Nope, it wasn't 2/3. It was 3/2. 3/2 x. Now let me make sure. The scrolling thing. So yeah, that was z. It's coming up there. Now when we simplify that, the 3's are going to cancel. So I get 5 over 2x. Now I could write the solution, the ordered triple, in terms of x. X would be x, and y would be 5 over 2x, and then z would be 3 over 2x. Now that's not the way I did it the first time. I did it in terms of z. So you can see the answers look different, right? One's in terms of z and the other's in terms of x. My guess is they will tell you what variable they want it in terms of, so then you would have to work with that. For me, it doesn't really matter if it was in terms of z or x. Actually, I would probably tell you on a test what variable to put it in terms of.